This is part 2 of our week 1 discussion material. What we're going to do is talk about how science examines natural hazards and how we can use that information maybe to make ourselves a little bit safer. So the questions for homework and discussion, just as a reminder, if you're watching this during the first half of the week, the first question is to develop a plan for successful completion of this course. So this is going to be due on Wednesday. So that's just a reminder, and the sub-questions are there. And you should be discussing this in the discussion group, and I'd like to have that by Wednesday night. So what we're going to talk about in this slide presentation is how are disasters studied by scientists, and what are the implications of the 5 fundamental concepts outlined in Chapter 1. So this is a geology class, and the hazards that we're going to discuss mostly are geological. Some of them fall under the auspices of some of the other sciences, but mostly we're working on things that would be considered geological, at least some aspect. So geology is just the scientific study of the earth. We divide sometimes geology into the study of the physical earth, the composition of the earth and its processes. And another way that we look at the earth is its history. Looking at fossils and rocks tells us a lot about how the earth has been in the past. A third way to do this is what this class is about, which is looking at the interactions between humans and the earth. And what we do is we take our understanding of the physical earth and our understanding of the historical earth, what kind of things have happened in the past, and we apply that to hazardous processes and the interactions between humans and those hazardous earth processes. So that's kind of the general scheme of what we want to do in this class and how we're going to approach our examination of hazardous processes. So how are disasters studied? We want to think about how science examines things and how that way of looking at the world differs from other ways of understanding the world. And in some ways, we like to think that that makes science special in terms of understanding some of these processes and developing explanations that we can then act upon. The long goal here is to develop an understanding that allows us to keep people out of harm's way. So in science, we approach things in a very methodical, specific way, and some people call this the scientific method or the scientific way of doing things. There are a number of steps that we tend to go through in this process. You don't have to follow the cookbook recipe exactly, but you do need to proceed through these steps in order for something to be considered scientific. We typically start with an observation. In this case, it's gasoline in the groundwater, but it could just as easily be an earthquake occurred or a volcano erupted. And the observation raises questions. In this case, where did the leak come from? They're a little more specific. Is it from the buried tank? But it could be more general than that. Just where did it come from? What caused this earthquake? Is there likely to be another earthquake? And once we have those questions, we can begin to investigate. We can look for possible explanations. A key aspect of a good scientific explanation is that it is something that you can investigate. It's something that you can collect data about and that you can test. Our goal with a proposed explanation is to see if we can prove that explanation is incorrect, if we can rule it out. It turns out it's very difficult to prove that something is true For example, in this case, if the tank leaks, that doesn't mean it's the only source of contamination. It just means that it's probably one source. It makes it more likely that it's the source because the groundwater could be flowing in another direction. There could be other sources. The sample we took could have been contaminated from something else. So we investigate things and we try to, if we can, rule out some of our possible explanations, and that lets us focus in on what's more likely, the things that remain. So in this case, you can see that they tested the tank. It didn't have a leak. It was the wrong kind of gasoline. And so they actually proved their idea to be incorrect, and then you have to move on to other possible explanations. And that's kind of how science looks at things. We go out, we collect as much data as we can, we come up with a conclusion, and it usually leads to more questions, as it does in this case. We still don't know where the contamination is from. Since we're so data driven, you'll observe as we go through this course that we look at two general types of data. Qualitative data is more descriptive, conveyed with words or sketches. Quantitative data is numeric. Many times people will have a preference for quantitative data. Those numbers, for some reason, feel more official. They carry more weight. And that's not necessarily true. Sometimes the numbers that we assign are more arbitrary than some people might think they are. They're not as solid or firm or conclusive as they might appear. So we have to be very, very careful when we use quantitative data to make sure that we're not taking it farther than is appropriate. On the other hand, qualitative data sometimes feels a little squishy. People could use different terms for the same thing, and so that makes folks feel a little uncomfortable with, exactly how far can I take this data because it's only descriptive. But that would be incorrect as well. Descriptive data can be excellent data, can be very useful. So what we have to do is realize that there are strengths and limitations to both kinds of data, and we just have to take that into account as we use it. We shouldn't necessarily be giving priority or preference to quantitative data just because it's a number. So the one very important thing that we need to do is make sure that when we collect either kind of data, that when we share it with others, we're very clear about what it is, how it was collected, and what we think it means, so that we try to reduce differences of understanding with other people. When possible, we like to use quantitative data to describe things just because it does help reduce some of the misunderstandings. So for example, if you say a sound was loud, loud might mean some very different things to different people. If we measure that sound in decibels, it gives us a number, it tells us how loud, but it also does not tell us other things about that sound. Is it annoying or is it something that's pleasant? So again, the quantitative data is helpful. It's something that reduces sometimes misunderstanding, but on the other hand, if that's the only data you use, it could be a little bit misleading. So that's our data sources. Something to consider as we go through the semester. So the other question that we have for the week is, what are the implications of the 5 fundamental concepts outlined in Chapter 1? And these are the 5 concepts right here. They're very important. You'll see them woven through the entire textbook. They show up in every chapter. Sometimes they're explicit, and sometimes it's just implicit. It's just implied. You can kind of recognize it's there if you're looking for it. So the first one is that hazards are predictable from scientific evaluation. Um, some hazards are easier to predict than others. Um, in a lot of the hazard sciences, we try to develop predictions with the assumption that if we understand the hazard well enough, we should be able to come up with some kind of prediction that people can use. Second bullet is risk analysis. We're going to talk a lot about risk analysis in this class. Very often it's a numerical analysis. It's a percent chance that some hazardous process will occur. And when you do your term project, that's an important aspect, something that you're going to want to try to figure out as best as you can. Sometimes we can get a really good solid number. Sometimes it's not very good. Sometimes it's kind of squishy. And sometimes it looks like it's really good, and when we dig into it in this course, we'll find out that it's not as firm as we might think it is. The third bullet will recognize that there are linkages. So we separate things into chapters in this book, but you'll very quickly find out that one hazard can lead to another. So an earthquake can result in a landslide. A landslide can block a river and lead to a flood. An earthquake can lead to a tsunami. Sometimes an eruption of a volcano can lead to an earthquake. So there are lots of linkages between these hazards that we'll want to recognize and try not to force things too tightly into a box. The fourth bullet, hazardous events that previously produced disasters are producing catastrophes. Chapter 1 discusses why this is, so you want to look into that and discuss it in your groups. Why this happens actually varies a little bit from hazard to hazard, but it is something that we're seeing. And sometimes it's just that we recognize the catastrophe that maybe we ignored in the past. And the fifth bullet is that consequences of hazards can be minimized. And that's one of the goals, is that we want to minimize the consequences of these hazardous processes to humans. One of the recommendations that I make to students discussing these concepts in your discussion groups is to throw this question out to the group. Ask the group members, which of the 5 do you think is the most important and why? It's a really good way to spark a conversation in your group. So if you're listening to this and you get to your group first, post that as a question. Which of the concepts do you think is most important? And that'll be one of your posts for the week. And then you can go ahead and answer it, or you can wait and see what other people say. This is a map from the book. It's just to kind of remind people that no place is free of these hazardous processes. This map shows flooding, volcanoes, tornadoes, earthquakes, hurricanes, and landslides. Those are 6 of the hazards we will discuss. You can see there's a nice coverage, really, of the whole United States. And even the places that look white, if you think about it, you've heard of various hazards occurring there as well. A hazard they don't show, for example, is wildfires. So that's one that occurs a lot in the western U.S. So what I want you to remember is to get into ReggieNet, get into your discussion group, discuss these questions for the week, and your homework is due on Sunday on the last 2 parts of the questions. And remember, the first part of the question, that homework is due on Wednesday. So that's it for this slideshow. Read the textbook and enjoy learning about how we study natural hazards.